Hi, students. This is me, Professor MD, and today our topic of discussion is Voltaic cell. We can also name it as a Daniel cell and a galvanic cell. Well, we have some little bit differences, but we will talk about the Voltaic cell because the mechanism of all these three are same. How will you recognize a Voltaic cell? So, in Voltaic cell, we must have these properties. In Voltaic cell, the chemicals, they are converted into electricity. So any cell in which chemical is converted into electricity, we will name it as a Voltaic cell. And during conversion of chemicals into electricity, a spontaneous redox reaction will occur. Spontaneous redox reaction. Spontaneous redox reaction will be that reaction in which one electrode, that is anode, will lose electron, and another electrode, which is cathode, will accept electron spontaneously. Will be no involvement of external battery in this redox reaction. So such type of reactions are spontaneous redox reaction. It is usually two chambered. Two chambers are involved in Voltaic cell. Two chambered. One is anode half cell, like you can see in this diagram. One is anode half cell and the other is a cathode half cell. Anode in Voltaic cell. Anode is negatively charged and oxidation occurs on anode, as we have already discussed in electrolytic cell. So anode is negatively charged and oxidation occurs on anode, while cathode will be positively charged in case of Voltaic cell, and reduction will occur on cathode. Salt bridge will be required because salt bridge, in the absence of salt bridge, there will be no continuous supply of electricity by Voltaic cell. So salt bridge will be required in Voltaic cell. Similarly, if we talk about the electron flow, so electron flow occurs in Voltaic cell from anode to cathode. So electrons are produced at anode and they will flow through a galvanometer, and galvanometer will show us the reading that how much voltage is produced from this electron flow, and they will move towards the cathode. Okay, if you look at now the construction of the Voltaic cell, so construction of the Voltaic cell in simple words be like this, that it consists of two chambers. uh, One is anode half cell and the other is cathode half cell. Anode half cell, the electrode is zinc, and we will take its electrolyte zinc sulfate. While in cathode half cell, the electrode is copper, and we will take its electrolyte copper sulfate. Zinc electrode potential is negative, reduction potential is negative, so it will lose electron. When zinc lose electron itself, it will convert into Zn plus 2 ion, and that Zn plus 2 ion will comes to solution, and the electron will move through wire passing through galvanometer. Galvanometer will show you the reading. E naught of the cell will be equal to 1.10 volt, and these electron will flow towards the copper. At the copper electrode, the copper ion from solution, they will accept these two electrons which are coming from the zinc electrode, and the copper ion will convert it into a copper neutral solid form. So if you look at these two reactions in anode half cell, zinc is undergoing oxidation because zinc is losing electron, so zinc is converting into Zn plus 2, And copper plus 2 is gaining electron, so it will undergo reduction. So we can say that in cathode at cathode half cell reduction occurs while anode half cell oxidation occurs. As E naught oxidation of the zinc is 0.76 volt and E naught reduction of the copper is 0. Plus 0.34 volt. So if you want to find out the E naught of the cell. So E naught of the cell will be equal to E naught oxidation plus E naught reduction. So E naught oxidation occurs at anode, and anode is made up of zinc. So we will put the value 0.76 over here, and E naught reduction occurs at cathode. So E naught reduction value of copper will be plus 0.3. If you add these two values, so we will get the result 1.10 volt. That is the electricity produced. Now there is a question. What is the need of a salt bridge? Why a salt bridge is used in Voltaic cell? So if you look at the mechanism over here, is at anode half cell, zinc ions are producing. If zinc ions are producing, so automatically the positive charges that increase, positive charge increase in anode half cell, positive charge increase. And as copper ions are consumed in cathode half cell, so sulfate ion will increase, so negative charge will increase in cathode half cell. So when the positive charge increase in anode half cell, so it will not let the electron to move towards cathode. So that's why the flow, the unit of the cell will drop to zero. So the voltaic cell will not produce electricity. So to avoid such a situation, we use a bypass, that is salt bridge. A salt bridge is a U-shaped tube, in which we use another electrolyte paste like KCl. We will use an electrolyte whose cation and anion almost have same transport number, or almost have same speed of migration towards opposite end. If you look at here KCl, in KCl the potassium carries positive charge while chlorine carries negative charge. So as anode half cell is positively charged, so all potassium ion they will move towards all chloride ion, sorry, all chloride ion they will move towards anode half cell. And why? Because this chamber is positively charged, so these negative charges they will neutralize this positive charge. Similarly, all the potassium ion they will move toward the cathode half cell, because cathode half cell is negatively charged, so the potassium ion they will neutralize this negative charge. So what is the function of salt bridge? Salt bridge connects the two electrolytes, that is zinc sulfate and copper sulfate, and it maintain the two chambers neutral. ये दोनों chambers, two chambers they become neutral, इन दो chambers को neutral लगता है. So that is the main function of the salt bridge. If we now represent the voltaic cell by a simple diagram, so that will be the diagrammatic representation of the salt bridge, voltaic cell. The diagrammatic representation of the salt bridge will be, I'm going to erase it. Okay, so the diagrammatic representation of the salt bridge will be, that of voltaic cell will be. So how will you represent it? Any voltaic cell can be represented by this diagram, that is called cell diagram or cell representation. In cell diagram, we uh, write the anode half cell, then the salt bridge, then the cathode half cell, and how much electricity is produced in the cell, that is written at the end of the representation. So if we look at here in voltaic cell, the anode half cell consists of a zinc electrode, Zinc electrode converts to, if I show it by, zinc convert into zinc ion. So there is a phase change occur from solid state to aqueous solution form. So for phase change, we will draw a single line. This single line represent phase change. Is the concentration of the electrolyte is 1 molar, so we will mention in standard electrode potential, we always take the concentration of the electrolyte is 1 molar. So the concentration of the solution must be mentioned. So zinc converts into zinc sulfate and a zinc ion, sorry, aqueous solution. Salt bridge is shown by two parallel lines. The salt bridge which separate the anode half cell and the cathode half cell. The copper ion from solution, it converts to copper solid. Again, a phase change occurs. The solution concentration should be 1 molar and the electricity is produced is 1.10 volt. So this is the representation of the voltaic cell. Thanks for watching.